Hello students, welcome to the course of Database Management Systems. I'm Dr. Munir Omar, and today in lecture number 49 we will study about database transactions. This is the agenda for our today's lecture. First, we will study about the transactions. We will have some basic concepts about the transactions. Then, why do we need transactions and how these transactions are evaluated. Also, the transaction processing will be discussed. After that, we will study about the asset properties of transaction. This is an important topic and this topic will be discussed in details. After that, we will have look into the transaction management in SQL, how these transactions are managed in SQL. We will also look at this. After that, transaction log for keeping transactions. The database management systems use some logs, so we will check these logs, and at the end we will have concurrency control. This topic will be discussed. While performing operations in the databases, sometimes we need multiple SQL statements to perform a single operation. So what we do, we combine all those statements into a single unit. That unit is referred to as the transaction. A database transaction is a logical unit of processing in a DBMS, which entails one or more database access operations. Means that transaction is a logical unit containing one or more SQL statements. A transaction is a program unit whose execution may or may not change the content of a database. Actually, the most important thing in databases is to maintain the data in a consistent form. So, this is obvious that whenever we do something with our databases, we must take care of our data. So, the transaction actually change the database from one consistent form into another consistent form. So it is possible that the execution of transaction may change or may not change the content of database. The transaction is executed as a single unit. Though this transaction is the combination of multiple statements, but it is considered as a single unit, a block of multiple statements. We say that the transactions take database from one consistent form into another consistent form. Means at the beginning of transaction or before the execution of transaction, the database would be in consistent state, and once this transaction has been executed, again this database would be in consistent state. So the database access operations which are held between the beginning and end transaction statements are considered as a single logical transaction. So if we have a block of statements and this block is executed well, means all the statements in that block are executed, then it is obvious that the database would be in another consistent form from one consistent form. And in case this block is not executed well, some of the queries are failed, or due to some reason these queries are not executed, then this transaction would be reverted and the previous consistent form will be rollbacked. Why do we need transactions? Any action that reads from and or write to a database may consist of. We have many things for reading and writing from database. It can be a simple select statement to generate a list of table contents. We have used select statements to get data from various tables. It can be a series of related update statements to change the values of attributes in various tables. We have already studied update statements. If we need to insert some data, if we need to change some data in the database tables, then we may apply the update statements to change that data depending upon some conditions. Uh, the action can be the insert statements to add rows to one or more tables, and it can be combination of select, update, and insert statements. So in transactions, we may have the combination of all these actions. Uh, in one transaction, we may have multiple select statements or update statement or insert statements, and also we may have a combination of all these statements. For better consistency, we need all these required statements to be in a single block. If we need multiple statements for a single operation, then it it is considered a best way to combine all these statements in a single unit or a single block. Uh, the most important thing is that in this way we will reduce the complexity, and also it would be better for the data consistency. Means that we will take database from one consistent form to another consistent form through transactions. Again, we have the definition of transactions. It is a logical unit of work that must be either entirely completed or aborted. If there are five statements in a transaction, I suppose that there are five statements and some of the statements don't execute due to some reasons. Let's say four are executed and the last statement got an error. So what will happen? The entire transaction will be aborted. Means the previous four statements would roll back and the database will be kept back to its previous form. Successful transaction change the database from one consistent state to another, one in which all data integrity constraints are satisfied. So if the integrity constraints are satisfied, then the database would be in a consistent form. Most real-world database transactions are formed by two or more database requests. The equivalent of a single SQL statement in an application program or transaction. So we need transactions to take database state that is in a consistent form to another consistent state. If the statement, any statement in the transaction got failed to be executed, so the entire transaction is rolled back and the previous state is maintained in the database. So in this way we keep the database in a consistent form and all the integrity constraints are satisfied. In DBMS, we have two classes of constraints. The first class is defined by the users to perform some particular tasks or to fulfill some particular requirements, and the second class of transaction is enforced automatically by the DBMS. So whenever we talk about the transactions are maintained by the DBMS, and the constraints regarding the transactions are also enforced automatically by the DBMS. So if there are some issues in the transactions, or let's say some errors are faced or some queries are having errors in the transactions, so those transactions will not be executed automatically by the DBMS, and the previous transaction queries or previous transaction statements will be rolled back. So these things are automatically incorporated in the DBMS to uh, enforce the integrity of database data. So we can say that all the transactions don't update the database. Some may reward, some may roll back. And the SQL code represents a transaction because database was accessed. So if we have a transaction, we can say that this database has been accessed, and either the changes are made and maybe these changes are rewarded, but we may have some additional code that will justify or that will show us that this database was accessed. Improper or incomplete transaction have a devastating effect on database integrity. So if I omit, let's say we omit this rule or this support from DBMS, then the incomplete transaction or improper transaction will also execute, and such type of transaction will put a negative effect on the database integrity, and the data inside that database may get an inconsistent form. We are going to have a sample case. Suppose we have a database, it has 6 tables and all these tables are interconnected. Now we need to perform an operation, and that operation will have multiple statements. So what we do, we will put all these statements in a single transaction, and then we will check the possible cases. So here we have a transaction. This is a sample transaction on the database, this one database. So the first is to create a new invoice. Here I'm going to create a new invoice. Let's say we create something here. And then the second thing is insert arrow in the line table. So here we have line table and we insert arrow here. Then the third thing is decreasing the quantity on hand by 1. Here we have the quantity by 1. Here we have the quantity on hand. So we are performing an update statement. This one is update. The previous two were insert. Then update the customer balance. Here we have customer and this balance is updated. So we are using update query. And then we have another thing, that is create a new account transaction row. So again, this is an insert row. Here we are creating a new row in this table. So we have insert statement. Now in this transaction we have 5 statements, 1, 2, 3, 4 and 5. These are the 5 statements. Some are insert and some are update. Suppose let's say this one got executed, this one got executed, these 4 got executed, and this one failed to execute. What will happen? Here the balance is decreased on purchase of something, invoice is generated, and this line is also updated, but the product quantity is not decreased. Let's say we have 10 items, one item is purchased, everything is performed for purchase, the customer has been deducted with some amount of balance, but this quantity is not reduced. So this is an issue. And in case of transactions, this entire process will be reverted, means that all these queries which were successful will also be cancelled or rollback to keep the database in a consistent form. And in case there is no transaction and all these queries are independent of any transaction, we have not used any block of code, so in that case these four will execute and this one will not execute, and the data in this database would not be in a consistent form because the quantity will not be reduced, but for this item the entire process will be done. Asset properties. A transaction is a very small unit of a program and it may contain several low level tasks, means that it is a block of multiple statements, and the transactions have asset properties. So in each transaction there must be some rules or some constraints which must be fulfilled. These are known as asset properties of transactions. These are atomicity for A, for C we have consistency, then for I we have isolation, and for D we have durability. So these are commonly known as asset properties. These are used to ensure the accuracy, completeness, and data integrity of the database. So first we have atomicity. Atomicity states that all the operations, the SQL requests or the statements of a transactions be completed. If not, then the transaction is aborted. A transaction is treated as a single, indivisible, logical unit of work. Atomicity states that if there are five statements, so either all these five statements must be executed or these must be aborted. Let's say four are executed, the fifth one got an error, so the four will not be implemented in the database. These will be rollbacked and the transaction will not be successfully executed. It would be rollbacked. Then we have consistency, ensures that the concurrent execution of several transactions yield consistent result. If we have multiple transactions executing in a single unit of time, then such type of scenario is known as concurrent execution of multiple transactions. And in such type of scenario, the end result would be consistent, means that there would be no conflict among these transactions. Multiple concurrent transactions appear as if they execute in serial order, one after another. So if we have multiple transactions, so they will appear as in sequence, they will not appear in a parallel execution form. In this way the data would be in a consistent form while having multiple concurrent transaction executing at the same time. Third, we have isolation. Data used during execution of transaction cannot be used by another transaction until first one is completed. So, if a transaction is performing some task on a particular set of data, let's say it is performing task on a table or a row or column in a table, so that part would be kept isolated and that would not be accessed by other transactions. we have different mechanisms to perform such type of operation. We can lock in item for a particular transaction, so that locked item will be accessed only by the uh, executing transaction, and rest of the transaction will not be able to access that item. Then the last thing in asset properties is durability. Indicates permanence of database's consistent state. Once the changes are made, then those changes would be permanent. When a transaction is completed, the database reaches a consistent state. That state cannot be lost even if the system fails. So once the transaction is executed successfully, the database state will change to another consistent state, and that new state will not be lost